Impact of solar-powered fountain on the performance of conventional solar still. Abstract and experimental analysis of conventional solar still, CSS, and solar-powered fountain when placed in conventional solar still has been carried out and reported in this research article. For this experimentation, two geometrically similar CSS with 1 square meter basin area from FRP material had fabricated. One of the still was placed without any modification and, the other solar still was set down with the solar-powered fountain. The objective of this experiment was to determine the impact that solar-powered fountain did on the performance characteristics of CSS and see the effect of this on the distillate output. The significant purpose of the solar-powered fountain in this experiment was to increase the evaporation rate and surface area. The distillate output obtained from MSS, modified solar still, is 35.63% higher than CSS, whereas the average cumulative distillate output of MSS compared to CSS has elevated by 101.34% because of the solar-powered fountain. Keywords: desalination, conventional solar still, solar-powered fountain. Nomenclatures. Accuracy. T_W temperature of water surface, OC. T_CI inner glass cover temperature, OC. U standard uncertainty. Abbreviations. AC total annual cost, ARS. AMC annual maintenance cost, ARS. ASV annual salvage value, ARS. OC annual water cost, ARS/L. CRF capital recovery factor. CSS conventional solar still. FAC first annual cost, ARS. GI galvanized iron, ARS. Indian national rupee. MSS modified solar still. SFF sinking fund factor. Introduction. Human civilization progresses into an age of machines. To attain these developments, we have been polluting our natural resources. One of the highly affected natural resources is water, and, also this topic was globally discussed by world leaders. 70% of Earth's surface is covered with water, but only 2% of it is fresh water. Rest is salty and brackish water, which is exiguous for the present-day population. Solar desalination is a promising technique that can be applied to transmogrify brackish water into distilled water. The solar still is advantageous to places with less access to water supplies as it is easy to fabricate, requires parts that are within easy reach, and costs less than contrasted to modern water purifiers. Solar still not only purifies salt and dirt but also removes bacteria in water to make it consumable. The various factors affecting the performance of the solar still are solar radiation intensity, wind velocity, ambient temperature, and the gradient of water surface and glass cover temperature, basin plate area, and glass inclination angle, depth of water. Solar energy is one such energy that is just not only free but renewable, sustainable, and environmentally friendly. Conventional solar still, CSS, is a passive device that works on the greenhouse effect and uses solar energy to desalinate brackish/salty water. The solar intensity, wind velocity, and ambient temperature cannot be controlled as they are a meteorological parameter, whereas the remaining parameters, free surface area of water, absorber plate area, glass cover inclination and depth of water, can be varied to enhance the productivity of the solar stills. Carlos Wilson I firstly used the passive solar stills, which are also popularly called as conventional solar stills, CSS, to supply fresh water to a nitrate mining community. The major drawback of CSS is its poor distillate output and requirement of a large surface area. A detailed review on the development of conventional solar still, CSS, have been reported by Kabil etal2 and Aub etal3. Jamil and Akhtar 4 have reported the influence of characteristic dimension, aspect ratios from 1.94 to 2.67, on the distillate yield of a CSS. Dumka and Mishra have presented a new method to increase the distillate yield of CSS by augmenting it with an ultrasonic fogger/humidifier 5,6. They have also reported a paper on comparative analysis of CSS and MSS, CSS augmented with permanent ferrite ring magnets, 7. Kumar and Tiwari 8 and Sharshar etal9 work aim to explore a new technique for improving the performance of solar stills, SSS, through utilizing three different types of a new hybrid structure of heat localization materials, HSHLM, floating on the water surface to increase the evaporation rate as well as water production and minimize heat losses. An exergo-economic analysis of a still for near coastal areas has been reported by Dumka and Mishra 10. Influence of cocoa peat augmented with solar still has been reported by Sharma etal11. The objectives of this research are as follows. Experimental analysis of instantaneous thermal efficiency of MSS and CSS. variation in distillate yield of MSS and CSS. 2. Experimental setup. For this experiment, 2 identical CSS with 1 square meter basin area made from FRP material. The thickness of FRP still is 5 mm whose higher and lower sides are 0.48 m and 0.2 m, respectively. The inner surfaces of solar still were painted black to achieve higher absorption of solar energy. An iron transparent glass of 4 mm thickness has been utilized to cover the still at an angle of 15.6 degrees from the horizontal surface. The solar-powered fountain used in this experiment has the dimension of 16 cm x 16 cm x 3.5 cm. Where, the fountain was placed in the center of the basin plate. The purpose of solar-powered fountain was to increase surface area and evaporative cooling. Fig 1 and 2 shows the photographs of CSS and MSS. 5 K-type thermocouples, K7/32-2 CTEF, have utilized for measuring atmospheric temperature, inner glass surface and outer glass surface temperature, basin temperature and water temperature in both CSS and MSS during the experiment. Temperatures have documented with the help of the DDC324A2 temperature indicator during the experiment. Where, A is the accuracy of the instruments. Table I shows the range, accuracy, and uncertainty of experimental instruments. The experiments have been performed in the month of May-June 2021, at JP University of Engineering and Technology, Guna, India. The duration of the experiments was 7 hr. After every hour, the following observations were made during the experiments. Glass, basin water, and atmospheric temperatures. Solar radiation intensity. Distillate per hour. 3 observations, results, and discussions. Fig 3 shows the variation of solar radiation intensity and ambient temperature as a function of time. At the start of the experiment, solar radiation intensity and ambient temperatures were 690 W/m2 and 26.6 degrees C, respectively. The maximum solar radiation intensity was recorded to be 995 W/m2 at 1330 H and, the maximum ambient temperature was 32.9 degrees C at 1330 H. At the end of the experiment, solar radiation intensity was 330 W/m2 at 1730 H. However, the minimum ambient temperature was 29.1 degrees C at 1730 H. The average solar radiation intensity and ambient temperature have been observed to be 764.375 W/m2 and 29.775 degrees C respectively. The variation of basin water temperature as a function of time in CSS and MSS has depicted in Fig 4. As TW of CSS leads MSS throughout the experiment, this is due to the evaporative cooling caused by the solar-powered fountain. The peak value of TW recorded for CSS was 44.7 degrees C at 1330 H, whereas MSS recorded a value of 41.2 degrees C at 1430 H, an hour delayed from CSS. Basin water temperature undergoes a total increment of 49.79% and 38.39% for CSS and MSS respectively. The average increment of basin water temperature of CSS in comparison to MSS has been observed to be 12.94%. Fig 5 shows the variation of temperature of inner condensing glass cover as a function of time. TCI of MSS leads CSS from the start of the experiment till 1630 H. After that, CSS leads till the end. The CSS lead MSS in the end due to the evaporative cooling effect caused due to solar-powered fountain placed in it. Peak value of TCI recorded was 38.6 degrees C at 1430 H and 36.3 degrees C at 1530 H for MSS and CSS respectively. The average glass cover temperature for CSS was 32.64 degrees C and for MSS was 34.78 degrees C. Increment from average temperature to peak temperature has been observed to be 11.2217% and 10.99% for CSS and MSS, respectively. The variation of distillate yield obtained from CSS and MSS has shown in Fig 6. The cumulative yield recorded from CSS and MSS is 0.811 and 1.1 liters, respectively. An increment in cumulative yield of 1108.33% and 200% was recorded for CSS and MSS, respectively. The distillate output obtained from MSS, modified solar still, is 35.63% higher than CSS. The average cumulative yield increment of MSS was recorded to be greater than 101.34% from CSS. The variation of efficiency of CSS and MSS has shown in Fig 7. During the entire experiment, MSS has been more efficient than CSS. MSS leads CSS by 5.83% in instantaneous efficiency recorded at 1730H. Instantaneous efficiency of CSS and MSS at 1730H was observed to be 29.53% and 31.26%, respectively. The mean overall efficiency for CSS and MSS has been recorded as 10.87% and 13.79% consequently. Augmentation of still with solar-powered fountain resulted in increment of overall efficiency by 26.86%. With the help of cost analysis as shown in Table 2 and Table 3, one can understand how solar fountain helps in the reduction of cost per liter, CPL. The CPL in MSS has decreased by 20.34% in comparison to CSS. All the above factors have been evaluated by the formulas given by Dumka et al. 12. 4 conclusions. Based on the theoretical and experimental analysis of CSS and CSS augmented with solar power fountain, the following conclusions drawn were: due to evaporative cooling caused by the solar-powered fountain, the basin water temperature of CSS is higher than MSS. The average value of increment of basin water temperature of CSS in comparison to MSS is 12.94%. The average value of increment of condensing inner glass cover temperature of MSS compared to CSS is 6.55%. The average cumulative distillate output of MSS compared to CSS has been increased by 101.34% because of the solar-powered fountain. The distillate output obtained from MSS is 35.63% higher than CSS. The increment of overall efficiency is 26.86% higher of MSS than CSS. The CPL for CSS was 5.5135 Rs/L and MSS was 4.5814 Rs/L. Acknowledgement. Authors are grateful to Dr. Dhananjay R. Mishra for his continuous support and guidance during the research.